A car going 50 meters per second can come to a complete stop in 70 meters. What is its acceleration? For this one, we're going to use the variables of awesomeness along with the equations of awesomeness, just like before. So I've highlighted the important pieces of information in the problem and put them in the chart. Pay close attention to the fact that even though there wasn't a number here, the fact that they said it could come to a stop tells us that the final velocity is zero. Look for that in problems. You should always be able to fill out at least 3 pieces of information in your variables here just from reading the problem. If you only found 2 of them, then you're probably missing something. But anyway, let's jump right into the problem and figure out which equation is going to do the trick. So out of these 3 equations, we're looking for the one that can tell us what acceleration is. Well, all 3 of them have an a in it. However, there's also a second thing that's important. This problem never told us how much time the car spent stopping. So any equation that has a t in it is not going to do the trick. We've got to find an equation that has an a but does not have a t. It's this one at the bottom that's going to do the trick for us, so let's use it. After plugging in the values from our table, I get this down here, and then simplifying, we get this. Now notice that the negative stuck around. Some people might ask, why did you get a negative number here if you did negative 50 squared? Well, the minus sign belonged to this entire term. It's sort of like this. In fact, I probably should have thrown some parentheses in it. It's like you're doing minus 50 squared. So the negative actually sticks around, and I wouldn't let that bother you on the final answer because that simply means that the acceleration was backwards, which makes a whole lot of sense because the car was slowing down. A stunt car must reach a speed of 40 meters per second to make a jump on a ramp. If acceleration equals 3 meters per second, how long of a head start does it need before the ramp? In other words, how much distance do you need before it reaches the ramp in order to reach that much speed by the time it gets there? Just like usual, we're going to list our variables of awesomeness and try to fill in what information the problem has already given us. Now on this one, they didn't actually tell you what the starting velocity was, and that's okay. You can just assume that it was 0, because it's asking how long of a head start do you need, so we're just assuming that it started from rest. And now we've got to find the correct formula to knock this one down. Now out of these 3 equations over here, we're trying to find one that has a delta x in it, but does not have a t in it. This one up here does not have a delta x, so it's not going to do the trick. How can we find delta x if there's no delta x in it? This one has a delta x, but it's littered with t's, and we would have to solve for t, which we could do, but it would take an extra step. If we do this one at the bottom, we can jump straight to the solution, because we have vf, vi, and a, and we're looking for delta x. So let's use that one. After plugging in the values, I get this. Remember to throw parentheses on all your values to make sure you don't make any mistakes, just like on the last problem I showed you. That keeps things nice and safe. And if you work it out, it looks like the car needed about 270 meters of track in order to reach that much speed to make the ramp to make this jump. For the next one, we've got Donkey Kong falling out of a very tall tree, and we want to know how long it takes him to reach a speed of 32 meters per second. Now this one looks like it doesn't give you a whole lot of information, but there's more to this problem than meets the eye. It actually tells us plenty if you look carefully. So just by looking at the problem, it tells you that he fell out of the tree. He didn't jump or throw himself down or anything like that, which tells me that his initial velocity was 0. He simply fell. It also tells us that he reaches a final speed of 32 meters per second. Well, we know that that's going to be in the downward direction, so his final velocity is minus 32. Be really careful here. But we need a little bit more. It feels like this thing's a little empty. But wait, if he fell, there's one thing that we always know is true for falling objects, and that's that acceleration due to gravity is always equal to minus 10, or minus 9.8 if you want to be really specific on the problem. So always fill this in if you have an object that's just flying through the air. Now, rather than listing all of the possible equations, I'm just going to tell you that this one does the trick. You can look at the other ones for yourself. This is the one that's going to help us find t, which is what we're after on this one. After plugging in the numbers, I get this. And with a bit of algebra, you get 3.2 seconds, which makes sense because he got 10 faster every second to reach 32.